Alright, in this video we're going to come back, we're going to make sure that we know how to use all aspects of Charles's law. You've already learned what the formula is. You've already learned that pressure is constant. You've already dealt with calculations with it. There are some things that are going to trip you when you work some of these. So let's try one that has a little bit of a trick and make sure it doesn't catch us. Let's say we have a gas that's at 2.4 liters and the volume's going to change to 780 milliliters. Now, temperature, one, was measured at 20 degrees Celsius, and it wants to know what temperature 2 is. Now, this is tricky because our units are messed up. I want to make sure that you understand this. If you work a problem in Celsius, it's automatically wrong. So the first thing we want to do is we want to fix that. So we don't want that number. So what I'm going to do is I'm going to use this formula. Degrees Celsius plus 273.15 is Kelvin. So 20 plus that's going to be 293.15 Kelvin. You have to work the problem in Kelvin. So I've got my temperature fixed. So this is the answer is going to come out in Kelvin. So I already know that. Now there's another quick problem, and the other quick problem is that my volumes don't match. Liters is a volume, and milliliters is a volume, but they don't match, and they're supposed to match. So I need to change one so that they match. The easiest thing to do is take the milliliters, back the decimal up 3 spots, and take the milli off, and so that's 0.78 milliliters. Now we did this same thing when we were doing Boyle's law when we had to convert units, but they have to match. So let's work the problem and see what we get. V1 over T1 equals V2 over T2. Remember, you better write the formula and plug your numbers in. So let's see what we get. Gas has a volume of 2.4 liters. There's that one. It changes to 0.780 liters. Those match. Very good. This is 293.15 Kelvin. We had to convert it. And there is X. To solve it, I'm going to cross multiply. So that means I'm going to do this kind of thing. So I see that it is 2.4 times X. That's this one and this one. Equals, grab my calculator, 0.780 times 293.15. That number is 228.657. Now you'll notice I didn't round because I'm not done with it. I'm going to divide by 2.4. And when I divide by 2.4, my answer comes out 95. So I wrote that wrong. 95.3 Kelvin. And that would be a great answer on a worksheet. Let's make sure it's to the right sig figs if we were on the computer. 2 sig figs, 3 sig figs. The original number, 20, had 1 sig fig. So you go off your original numbers. That's 1 sig fig. So 95 is going to round to 100 Kelvin. Now, that one's sort of tricky. The 5 makes the 9 round to a 10, so it becomes 100. Realize that's a placeholder and that's a placeholder. So 100 Kelvin would be the answer that you'd want on the computer if you were on that. Let me move that up so you can see it better. It would be 100 Kelvin there. But 95.3 is the answer I actually got on my calculator when I worked it out. Now, a couple of things to be careful with. You have to watch your units. They have to match. And temperature has to be in Kelvin. Let's try one more real quick. A gas has a volume of 2.3 liters. We don't know the new volume, but we want to know it in milliliters. If temperature 1 is 25 degrees Celsius and temperature 2 is 31 degrees Celsius. To work this problem, the first thing that should jump out at you is you have temperatures that are in Celsius. That's wrong. I'm just going to put a line through it, and I'm going to fix them. So I'm going to take my calculator, 25 plus 273.15, and I get 298.15 Kelvin. And the other one is 31 plus 273.15 is 304.15 Kelvin. Remember, it always has to be in Kelvin. And so I'm going to plug it into the formula. V1 over T1 equals V2 over T2. And I automatically see that this is in milliliters, liters, and it wants milliliters. So when I get my answer, I'm going to have to change it to milliliters to get the answer. So when I plug the numbers into the positions that they will actually represent, I have a volume of 2.3 liters, a temperature of 298.15 Kelvin that goes to 304.15 Kelvin, and there's my X. I'm going to cross multiply to solve, so that's 298.15X, that's those two, equals, and I have to grab my calculator again, 2.3 times 304.15. Long number, 699.545. Not going to round yet, because I'm going to divide by the 298.15. Again, simple algebra, not very difficult. We're good at Algebra 1. So I'm going to take that number divided by 298.15, and I get this answer. 2.35. What units? Well, when I'm working the problem, Kelvin, Kelvin, liter, this is liter. And so I have to check my sig figs. I know that I have to go to milliliters. I'm going to do that here in a second. But I'm going to go 2 sig figs further. They're all 2 sig figs. So it's going to go to 1 to stop. That's 2.4 liters. And then I have to turn it into milliliters. Well, when you go to milliliters, the number is going to get bigger. So I go 3 spots. 1, 2, 3. 2,400 milliliters is the answer. And that is to the correct number of sig figs. So when I got the answer, it's going to be in liters, but it asks for milliliters. So I got my answer, put it in the correct sig figs based on the original numbers, and then I move the decimal so that it's in milliliters. Read your questions carefully. Now, quick hint. Quick hint, and we're done so that you can practice some on your own. Let's say, just to practice, let's say that they gave you questions, and we won't do the math here, but watch carefully. Let's say this is 1.4 liters, and this is 2.75 liters, and this is 25 degrees Celsius, and they want to know this temperature in degrees Celsius. Can I work the problem the way it is right now? The answer is no. I can never work a problem in Celsius at all. But even though they want the answer in Celsius, I have to work the problem in Kelvin. So I'm going to convert this to Kelvin, work it, get an answer in Kelvin. When I get the answer in Kelvin, how do I get Kelvin back to Celsius? Well, if Celsius plus 273.15 is Kelvin, when I have a Kelvin answer, I subtract 273.15 to get Celsius. So I work the problem in Kelvin, so I get an answer in Kelvin, and then I subtract 273.15, which gives me the answer in Celsius. Now you may think, okay, I don't understand why you're having to work them in Kelvin and Celsius, and excuse me, Kelvin instead of Celsius. Here's why. If I were working this very simple problem in Celsius, if I'm working this problem and I cross multiply and solve, that's 80, and that's negative 20x. When I divide by negative 20, if I stayed in Celsius, my answer is negative 4 liters. Now look at that number. I went from 2 liters to negative 4 liters. There's no such thing as negative liters. You can't have negative liters. So you had to have a temperature scale that can never be negative. Celsius can be negative. Kelvin is never negative. So you have to have a scale that is always positive. In the next set, you're going to practice some problems on your own. Be very careful with your units. Make sure they don't trip you with inaccurate units. You may have to convert. Plug them in and solve each of them very carefully. You're getting good at Charles's law. Just be very careful. Good luck. See you in the next video.